An Arduino board that we use has 14 digital pins and 6 analog pins that can also work as digital pins. That means we can use a maximum of 20 pins as output from the Arduino. What if we need more? What if we wish to use 64 LEDs and want them to blink individually? It will be impossible by using only the Arduino pins. We can solve this problem by using a serial to parallel converter IC. That is the one that we are going to talk about is 74HC595. That uses only 3 pins from the Arduino. One for data out, one for clock shift, and one for latch, in order to use with as many devices as we want. This is a serial to parallel converter. This converts a series of binary numbers into parallel. Let us first understand the binary number system and about the most significant bit and the least significant bit. Let me start explaining the number systems by explaining the decimal number system first. This is the number system that we use normally in our day-to-day lives. So if I say I'm 58 years old, so that 58 basically comprises a decimal number system. If I say this is the year 2025, 2025 is actually a number from the decimal number system. A decimal number system basically it has a base of 10. So there are 10 digits in this number system. So the numbers are 0 to 9. So 0 to 9 are 10 digits. Let us understand a number. Let's say I have a number 595. In 595, the first 5 is actually on the hundreds place, and the next is on the tens place, and the next is on the units place. Did you notice that the digits on each place are actually multiplied by 10 for figuring out the next place? So 1 into 10 is 10, 10 into 10 is 100, 100 into 10 is 1000, 1000 into 10 is 10,000, and so on and so forth. So because the base is 10, we are multiplying each place by 10. So what is this 595 actually denote? 595 basically denotes 5 multiplied by 1 plus 9 multiplied by 10 plus 5 multiplied by 100. So it is 500 plus 90 plus 5, which becomes 595. So that is the final number that we got. Okay. Similarly, if you have a number 2023, so 3 is on number on unit place, 2 is on 10 place, tens place, 0 is on the hundreds place, and 2 is on the thousands place. So 2 into 1000 plus 0 into 100 plus 2 into 10 plus 3 into 1 becomes 2023. Did you notice that uh, the every place has actually a different kind of a value? For example, if I take 123, although 1 is a smaller digit, but because it is on the place of hundreds, so this has the most value. So this 1 is not just 1, it is a 100, and this is not just a 2, it is 20, and this is actually only a 3. So out of this 1, 2, and 3, 1 is called as the most significant digit, and 3 is called as the least significant digit. Least significant means it is the least important. This one is the most important. Although this is very small, it is the most important. For example, if I talk about this number over here, this one is just a 1, but this is actually 100,000. It's not 1. This is 20,000. So it's this, although 2 is larger than 1, but 2, because it's on the placeholder of 10,000, it becomes a 20,000. So most significant digit and the least significant digit we need to figure out. Okay. Next, we come to the binary number system. In the binary number system, we actually have the multipliers that we are going to use is 2, because the binary system has a base of 2. So we start off with 1 again, and we can keep on multiplying them by 2. So 1 into 2 is 2, 2 into 2 is 4, 4 into 2 is 8, and then 16, then 32, then 64, then 128. So basically, I'm talking about a byte here. This is 1 byte. 1 byte comprises of 8 bits. All right. Let's talk about this number. This is 110111. So basically, every binary number system will have only two numbers. It will have only a 0 or a 1. All right. How do we figure out what is the value of this number? How do we figure out? We keep on multiplying the number here with its placeholder. So 1 into 1 plus 1 into 2 plus 1 into 4 plus 1 into 16 plus 1 into 32. We leave out this one because this is actually a 0, so it will have a value of 0. So when we do add all these numbers, the number is a 55. Let me change this 1 to 0 to a 1 and see what happens. The number changes to a 63. So this is now a 63. So 111111 is actually a 63. Similarly, if I just take a smaller number, say 101. So in 101, it is 1 into 1 plus 1 into 4. So this is 1 into 4 is a 4 and 1 into 1 is a 1. So 1 plus 4 is 5. So total is a 5. If I make this as 111, it becomes a 7. If I make it as 100, if I make it as 100, it becomes 4. Out of these digits, whatever number of digits are there, the digits on the leftmost side is the highest significant has the highest significance. This we call this as the most significant bit, and the one which is on the rightmost corner is the least significant bit. Now we have understood the most and the least on in decimal number system, so the same thing applies here also. For example, this is also a 1, that means the one on this side, and this is also a 1 which is on the right hand side. But both of them have different values. This one has a value of 128, whereas this one has only a value of 1. So we now know which is the most significant bit and which is the least significant bit. So while working with the 74HC595 IC, we will be talking about most significant bit first and least significant bit first. You should know which bit is actually going first. The one which is on the left hand side or one which is on the right hand side. We did a manual calculation of a decimal number to a binary number. This table also shows a similar kind of a thing. So if I take a 0 here, 0 is a single bit, and this is the only bit that we are talking about here. All right. So suppose I need a number, I want a number 64 over here. So what happens actually is we keep on dividing the number by 2. Whatever is the quotient we write here, and whatever is the remainder we write here. So when we divide 64 by 2, the quotient is 34, remainder is 0. We are basically concerned with remainders only. All right. So 32 divided by 2, remainder is 0. Next is 16 divided by 2, the remainder is 0. 8 divided by 2, 0. 4 by 2, 0. 2 by 2, 0. 1 by 2, 1. And that is all. We stop dividing here. And we add these, we put these numbers together starting from the bottom to the top. So that means when I write the numbers as 1000000, this is actually 64 in decimal. Let us take another number. Let us take, say, 122. So again, 122 divided by 2 is the remainder. The quotient is 61. Remainder is a 0. Again, you keep on dividing. The remainders are 0, 1, 0, 1, 1, 1, 1, and you write these numbers from bottom to the top, and the numbers are 1, 1, 1, 1, 0, 1, 0. So this is basically equal to 122. So anyway, let me write the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you can figure out how to write the numbers. For example, a 1 is a 1, whereas a 2 is a 1, 0, a 3 is 1, 1, a 4 is 1, 0, 0, a 5 is 1, 0, 1, a 6 is 1, 1, 0, a 7 is 1, 1, 1, an 8 is 1000, a 9 is 1001, and a 10 is 1010. Anyway, you can figure out now what these numbers mean, what do these numbers represent. Let us learn how to convert a decimal number to a binary number. Let's take a number, say a number 69. Okay. Now you keep on dividing it by 2. The quotient you write on the bottom. So this is going to be 34. 34 to the 68. And the remainder you keep on writing on the right hand side. Now you divide this next number also by 2. So this is going to be 17 to the 34 and the remainder is a 0. So write 0 on the right hand side. Now 17 divided by 2 is 8 and the remainder is a 1. Take again divided by 2, 4 and remainder is 0. Next, next is 2 to the 4, remainder is a 0. Then 2, 1 the 2, remainder is a 0. Now we will stop this division when we reach a 1. Ultimately we will reach a 1. And now you write all these numbers from bottom to top. So that means we'll start with this 1, then 0, then 0. So it is actually 1 0 0 0 1 0 1. So there are 7, how many digits? 1 2 3 4 5 6 7, and there are 7 digits. So basically this number, which is a binary number to the base 2, is equal to 69 to the base 10. Let us take another number. Let us now take a number, say 200. So 200 divided by 2 is 100 and the remainder is a 0. So 100 divided by 2, the answer is 50 and the remainder is a 0. Next, 2 is 25 and the remainder is a 0. Next is 2 12s are 24, remainder is a 1. Next, 2 6 are 12, remainder is a 0. Next, 2 3s are 6, remainder is a 0. 2 1s are 2, remainder is a 1. So because we have reached 1 at the bottom now, we will stop the division now and we will write all these numbers from bottom to the top. It is going to be 1 1 0 0 1 0 0 0. So this to the base 2, which is a binary number, is equal to 200 to the base 10. The next step is to convert a binary number to a decimal number, so that we can do both the calculations. We know how to convert a decimal to a binary and a binary back to decimal. Okay, so let us start. Let's take a binary number. The binary number is 1 0 0 0 1 1 0. Okay, so what you do is on the top of the last digit you write a 1 and you keep multiplying this number by 2 and keep on putting on the top of the next number. So 1 multiplied by 2, double of 1 is 2, 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64. So that means on the top of each of these digits I have written, starting with 1, I kept on doubling. Why am I doubling is, why am I using multiplying it by 2? Because binary has a base of 2. Now what you do is multiply the number on top with the number below. So 1 into 0 is 2, into 1 is a 2, 4 into 1 is a 4, 8 into 0 is a 0, the next is a 0, the next is a 0, and the next is a 64. Now you add all these numbers. 64 plus 4 is 68, plus 2 is 70. So the number is 70. So that means 70 in decimal is equal to the number that we wrote in binary. Let us take another number. Okay. The other number is 1, 1, 0, 1, 1, 1. Now start writing with 1 on the top, 1 and then 2, then 4, then 8, then 8, then 16, then 32, and lastly 64. Now write down the number. 64 into 1 is 64, 32 into 1 is 32, 8 into 1 is 8, 4 into 1 is 4, 2 into 1 is 2. Rest are zeros, so I'm not taking those numbers. So what is the total? The total is 110. So 110 to the base 10 is equal to 110, 1110. So it's not a big deal. You just keep on, you write the numbers and you write down the numbers on top, starting with 1, keep on multiplying it by 2. So 1, 2, 4, 8, 16, 32, 64, 128, and so on and so forth. You get the decimal number. What if I want to convert this 110 into back into binary? So I will now take the 110 and now divide it by 2. So this is 55. The remainder is a 0. 2, 27. The remainder is a 1. 2, 13. Remainder is a 1. 2, 6. The remainder is a 1. 2. The remainder is a 0. And 2 ones, and the remainder is a 1. If I write these numbers from bottom to the top, it becomes 110, 1110. This is exactly the number that we actually started off with. 110, 1110. Exactly. So what we did in this particular program is we converted this binary number to decimal, and then we checked again by dividing it by 2, by converting it back into binary.